Yeah, just a couple words about the presentation, how it's going to go. I'm going to disappoint you guys a little bit because it's, even if it's AI part observability, there's going to be basically about observability in general and just a couple of points about whatever you can do with AI and also try to include observability of AI, like currently basically LLM. So I'm not by any means expert in this field. It's just I've dealt with such a systems or in general the complex systems in my career, which is about like 20 something years now. So and currently we're dealing with over like 20 customers at the time, and so we have to standardize and maintain. So basically, I'm going to bring in whatever topics I've encountered so far, and in some areas, I'm quite deep in some. I even have no clue what's even kind of written here. So it's just, again, the other thing is this is designed for C-level people to just understand what we're dealing with. So it's not really deeply technical. So also consider that. You might find even some problems there in the slides. So don't kill me for that. Yeah, let's see how it goes. Also, I've noticed we have we try to split this into those 4 areas. Let me just get to the next one. Or 5 areas, but things are not super smoothly, like flow-wise organized. So let's get into the first chunk of things. So yeah, basically cardinality. That's I mean, this whole chunk is telling about why observability or monitoring fails. It's like the first problem that is it's a cardinality. So it's causing performance pain. The queries are not fast, and things are like systems are growing. So it introduces a lot of issues, and the dimensions they are growing and blowing things up. And the challenges with this is basically this is going uncontrolled. So you introduce new tools, and they bring on dimensions, and you don't have much control over that. So I rarely see people going and doing something proactively. They're just pretty much bringing in whatever is there, and then dealing with consequences. So on our end, we're trying to control this somehow. Yeah. So per user, per request labels, that's another problem. So you introduce too much detail, which is a problem from a regulation perspective, and also like it adds too much data, which you don't want to have. And the other thing is cleaning those things up. So the other problem is event correlation. So we have a bunch of types of data. So so we'll see later. The biggest problem is like you want to correlate. So you want to correlate your metrics, traces, and logs together. Not sure about profiling, so that's what we'll explore. And why you want to do that? So you can reason better, and then you can jump back and forth between your different toolings. So you can then understand what's causing those problems. So you want to do less context switching. So you don't want to just approximately correlate stuff, but you can really pinpoint to specific things. So the challenges here you do with different tools, and those days, I don't know, you can see some icons here. So the most popular tools are Datadog, Grafana Stack, Clouds push on tooling. So Honeycomb is in this case specifically about traces, but and Sentry Stack, which become a thing recently. So I've seen like people like developers tend to go to the Sentry or Datadog, and infra guys tend to more go to the Grafana Stack because you can also run stuff in-house. So basically back and forth between those systems is really pain, and you deal with many events, and correlation is done pretty much manually. So another problem is basically service dependencies and the graph. You want to understand what those bring to is as a blast radius, understanding when something happens, which components are basically involved, and where are dependencies, what is causing problem where. And the other thing is so this gives you a clear ownership over over the boundaries and the services, so you know whom to chase and whom to talk to. So some services bring this out of the box, like Datadog does a good job. With Grafana, you have to do it somewhat manually. So challenges with those things is things get out of sync, and you have to basically, I mean, one option is, which is the default one, you document those. Best case scenario, you have it somehow written in your Confluence or Notion or somewhere, like some sort of diagram, but this gets out of sync super quickly. So my favorite one is live diagrams, which are actually showing you your state and showing also the problem. So yeah, and the problems with this is like it can get out of sync, as I mentioned, and if you get super complex setup, then it gets really like messy and it's hard to basically understand and clearly link those things together. So that's another concept we have to, or I would strongly encourage to deal with and find a good solution for this. So yeah, noise reduction, signal hygiene. Yeah. So what this means, like we have a bunch of recently, all those tools became popular. Before there were very few, and then companies started dealing with the consequences of those, which is a cost. So we need to keep those this hygiene clean, like good, in a good condition. So we have meaningful alerts, and yeah, we also try to optimize on our end for our customers to have really clear messages and alarms and whatsoever that can actually really point to the problems, not create issues. So yeah, this is important for that. And then it obviously reduces your incident cycles and builds the trust, because if you're just noising, like sending some noise to people that just stop even bothering to watch or react to the alarm. So yeah, challenges with this is like over time you accumulate a lot of stuff. So, and people just don't want to clean stuff up. And as a result, you don't know what to do with those. Like ownership is that problem. So, and you just create temporary debugging stuff, and then it never gets removed. So at the end, you don't know if you should delete this or it's going to create a problem. So that's more organizational challenge, but something that you guys have to somehow deal with. Yeah, threshold-based alerting is like basic type of alerting that you need to have. It's like standard that everyone pretty much has, and it's simple to implement, it's fast. And so it's like if you level observabilities somehow, this is first basic level, and everyone does it to some extent, hopefully. So yeah, it's clear, explainable. There's not much magic happening there. It's baseline, and yeah, it's not ideal, but gives you good safety net. The challenges with those is like you just pretty much copy, don't tune, then you end up with issues again. You don't want to, like this one ends up creating a lot of noise. So you have single static value, and yeah, and you don't have a historical data analysis and like delay. So it's like just pretty much a single line. That's why it's not, again, ideal. And there are better solutions to this. So the other topic is cost governance. Again, we're talking about this monitoring failing to for new generation of the system. So cost governance is most important. It's quite important part. So observability can get costly with more tools coming in. I think Datadog is quite expensive. That's why some companies tend to run stuff in-house, though it's, again, debatable. Sentry is becoming a thing, and that's also like slowly gaining, it's also slowly bringing more and more cost. So it's quite difficult. Yeah, there has to be some ways to control this. And yeah, basically trade-offs are mostly about retention and the volume of the signals being exported to those systems. And yeah, so basically you need this to justify your observability. You need to really good control, good sort of amount of visibility over this. So you need to take care of this one. The challenges is like per team cost. It depends, again, what kind of company are you taking care of. If it's a really big one, then it becomes a bit hard to control. If it's a small team, then yeah, you rather can pinpoint to whichever team is causing most of the cost. So recently we had a blow up, and then that pretty much ate the entire budget, and then spike protection kind of didn't take care of that. So those kind of things happen. It's also in this topic. So yeah, retention, you have to be careful. Basically configure retentions properly if it's about logs and also traces to clean them up, and also metrics. It can become very expensive. So yeah, basically now we're getting into the important sort of concepts, things we're dealing with. So metrics, it's I think most basic one after logs. That's what you guys already probably deal with. Yeah, it's what is it? It's super cheap, and it's easy to understand the system, and it gives you a really strong foundation to build your basic dashboards, alarms, and SLOs if you do such a stuff. It's quick to detect issues. As I said, it's very basic. Problem with this, it can get sometimes over aggregated, and those happen in aggregation itself and collecting, and it can happen also when building a dashboard. So usually if you flatten too much, then you don't notice actual spikes. That's one of the problems. No clear convention. So if you're collecting from different places, then you get a lot of duplicate, and basically you need to somehow regulate this. Again, it depends how big is your team. So if it's small, then it's okay. But if you deal with multiple teams, then whoever is taking care of the observability has to make sure that the standards apply there. So, and metric types, sometimes you just misinterpret, and we have a couple of occasions where teams complain that dashboards are slow and storage is slow, but in reality they were using wrong metrics. So they were aggregating with a function that wasn't meant for that type of data. And as a result, they had to just change it, which pushed us somehow also to change the storage, which we wanted to do anyways, but still problem is not on one end. So yeah, those are about metrics. The logs, which are even simpler. So you know what's that for? It gives you detailed context. So it has to actually come second. So first you have to understand what's happening with your system, and then basically you have to be able to measure and then go deeper, diving to understand what actually caused it. So it gives more context. It gives you auditability. So, and you need to be able to split those into two different sort of buckets, and have the audit logs in somewhere isolated. No one can actually even access. And basically it gives you option to reconstruct and reproduce and understand basically what happened to your system when something went wrong. Or so problem is unstructured logs. Different stacks expose different sort of logs. Some developers choose to not even log. So for example, for Kubernetes or runtime environments, they don't choose to output into SDL, so it goes to somewhere. And then if you're trying to access and understand what's happening, you don't see any logs. So then you have to deal with that. So that's biggest problem I've dealt with. Or debug logs. It's causing a lot of problems, and there is no variable or no means to, without bothering developers actually, to control those kind of things. So that's also unsensitive data. That's probably, I don't know, considering GDPR is probably the biggest problem from legal standpoint. Those, if you have a team or a security person, once in a while they're supposed to go to the logs and make sure you don't have stuff, or you have some ways to automate this. So you need a mechanism, but this is something you have to take care of. Traces, hopefully you guys know what's that. And surprisingly, a lot of people just don't use it. And we have to push developers to instrument. So basically, this is your debugger for distributed systems. If you don't use it, please go and learn about that and push, I don't know, do what, but get your teams actually using traces. It's much better, I don't know, maybe 10, 20 times better than logs. Pretty much solves the same problem, but you can correlate stuff much better. You can see basically what happens to your distributed system, if you are doing distributed system, which you probably should be doing. So it really gives you great visibility, and you can debug performance problems, latency problems. You can understand what caused that. Sentry has a replay feature. I don't know, probably other systems also have it. With that, you can even, if you instrument all your layers from the front end, you can pretty much understand what user did that caused that particular issue. So that's really great tool. Costly, but still, it's fine. We will talk about the instrumentation later. So yeah, basically it's going to give you visibility, confidence, and understand complex topologies. So if you deal with more than 2-3 components on like services, then you must have this implemented. Otherwise, you are just, I don't know, bleeding money somewhere else. So yeah, debugging, latency, cross-service failures, that's, yeah, I've mentioned already. Challenges. Yeah, sampling is a problem, and controlling this sampling is also a problem, though these days there are lots of tools, like, again, I'm going to talk about Sentry because we deal with that a lot. So Sentry brings in relay where you can control the stuff, so basically you don't waste your budget, but you have to be careful to not to oversample. Yeah, trace IDs, I think it's a technical rather problem. So if you instrument it properly, then you should have trace IDs in place so that you can correlate stuff. I've seen that people use traces, but they actually don't link them together. So they have individual applications and spawns in individual applications separately. So it's kind of doesn't make sense to have traces and not have that. So that's like really the biggest feature of this. And yeah, all those ones supposed to be basically background jobs. That's something also people don't cover, which depends. Like you can have some asynchronous job happening in between of the request, so you can also instrument those, and it again will give you great visibility, and troubleshooting issues will be much faster. I mean, you can imagine instead of using debugger when you're coding, you use some sort of exit. Old school stuff. So this is very much that topic. So yeah, spans. This is details of the traces. What's worth mentioning, it basically contains the information. It gives you context. So traces are giving complete chain, and the spans are giving you actual detail. So yeah, you have to make sure that you integrate good enough context, which you can basically ship from the application whenever you're exporting those spans, or yeah, auto instrumentation also does it. But you have to be careful to not have too much stuff there, to not have just to have enough attributes to see what's happening, and to not really expose too much data, because sometimes you just like pouring context in there, and so you deal with the customer data in observability, which is it's leaking basically your system, so that's not good. And libraries, yeah, you have to deal with upgrades of the libraries. That's also sometimes bringing inconsistency. We had a couple of cases where basically some, I think it was Next.js thing, mutating those what's called the headers, and it was really causing trouble. And we spent like 3 days trying to understand why those things don't get together. So it ended up being just a version inconsistency. That's something you have to deal with. And the problem with the tracing and the spans, usually developers justified, okay, it's tricky to implement, which is, but as soon as you learn, then you can just reapply to other services. It's a steep learning curve. And actually, we even have like a couple of instrumentations open source somewhere in a GitHub. So feel free to use those or pick something else, but this shouldn't be basically an excuse not to use this. This is so far my favorite tool, and if I would have a choice to pick one, if I would be forced to choose just one of them, I would go for traces, because it would cover quite a bit of cases. You can extract the rest from the traces themselves. So profiling, that's another great tool. It's a different category. You might have also dealt with that. At least back in the days, we could do it in our own machines, but now you can do it in cloud too. Again, we dealt with Grafana Parascope. That's great stuff. We literally, like a couple of days ago, troubleshooted and found some event loop problem in Node.js by, I don't know, some stringified, JSONified, whatever function, and we removed it, and it's, so I helped to, but for about a week or so, we couldn't really understand what's happening. So we could see it's there, but which exact function? So instrumentation, again, tricky with this one, might be. So you do it whenever, I think maybe I'll try to go to the flow. I'm pretty much being creative now. So it gives you a clear view where your resources go, CPU, memory, and even like if you have a IO network whatsoever, so you can see on a function level, this flamography gives you really good understanding where your time goes, and it justifies basically optimization. So what was happening with our team, the guys were just like poking random places, trying to find the problems, which I really hate. I want to be able to clearly make decisions like based on, and random is okay, maybe sometimes it's good, but if you're dealing with stress at the moment, you have to really super fast optimize, and you need the data to make decision. So if first 5 minutes don't give you a result, then you have to be structured. So this is really clearly justifying, helping you to, basically you tune, no guesswork, you just know where to do. So problem is teams, developers fearing of profiling, they think it gives or adds an overhead, which it does, but it's not like, I don't know, super high, maybe 5%. And I'm sure you can deal with that, and you can put it under the feature flag or some environment variables, switch it on and off. That's not a problem. So the other problem is like, it's a bit tricky to deal with those things, but as soon as you pass through this learning curve, then it's just like your best friend. And so profiling is used only for crises. So that's what I was trying to say. Don't do that when there is a crisis. Try to instrument, at least educate your team to at least one person to deal with this tool before a crisis will happen. Because when it happens, you want to have someone like who knows how to deal with that. So that's profiling. Labels, attributes, I think it's same issue as with the span. So you can, you have to standardize it. So it gives you a good tool to be able to organize stuff. You can use anything. It's like labeling, tagging, anything. You can apply to logs, metrics, traces, pretty much everything. I'm not sure about profiling, but So it gives you, you can standardize it. I would strongly encourage that you have some sort of documentation and tell everyone how to actually apply labels. Then it's easier for later to create data, so people know where to and what to look. And some storages even force you to do something like that. Otherwise, they become super slow. So it's pretty much like indexing. And so ad hoc analysis, which kind of contradicts with the concept of the labels, because it brings structure, but then it's a ad hoc. But you can auto label some stuff, so it's still easier, faster to do ad hoc analysis. So challenges, you need to standardize it, as I mentioned, and you shouldn't make it like super, high cardinality. This is going to explode your cost again, which we spoke about earlier. And I think the libraries bring default labels, but it's not standardized again. So different libraries think about this differently. So I, again, would recommend just looking into and at least having some basic convention, or maybe understanding that there is no convention, which is also fine. So histograms, I'm not super into this one. So we use in a couple of places, and I'm also not very much into the statistics. So I know there's P somethings, and we're using it very much when basically showing latency issues to the management to actually tell them what's exactly happening, because sometimes they just complain something is slow, and you have to convince them that it's okay. Once a while, a couple of requests, it's okay to have them slow. So basically it gives you percentiles. You can clearly understand what is happening, not just average, because average is lying. So you see the distribution between those percentiles. That's also perfect stuff. And then you can build the SLAs to really understand what's happening. So the challenges with this is like sometimes those buckets are not just even implementative, especially when the metrics are coming from applications themselves, like developers do this. Like I mentioned, so we had the case the dashboard was built on a wrong metric because it wasn't properly wasn't exported using right one. So that was a problem. Averages instead of percentiles. It's like standard stuff. So if you don't have those, then you end up with this one. And this can also explode your costs. So you have to be careful to not have too much, whatever is. So if you're measuring P99, then just export that. That should be enough. It's a problem because you have to deal with that. You have to basically educate developers, make decisions of whatever brings you more thinking, then it creates additional work and mental load. You can go with just a standard framework and that's fine, but it's up to you basically. If you want to cost optimize, then you need to do this. If not, then you can go with the average set. So exemplars. So basically there is a way to in the metrics points, which I've learned recently, by the way, in the metrics to point to specific trace that is actually causing that spike. So you can integrate those tools, and it's a great stuff. I'm going to explore more in your future. So whenever you have charts in Grafana, for example, you can see those points and you can click and then you will jump to specific requests that actually caused that spike. So it's really cool stuff. It's not just regular back and forth between logs and traces, which is kind of default, but it's between metrics and traces, which is awesome. So it speeds things up quite a bit. Problems with exemplars. Let's see, sometimes they just varnish, so they cleaned up, they sampled, so you don't really see them. Correlation ID is not consistent, like properly instrumented, so you also have a problem there. And I mean, engineers are aware of exemplars, which I was also like a couple of months ago. So you need to know that those kind of things exist, and then you can greatly benefit from this. So enrichments, that's like you can take the data and then add additional stuff. Like OpenTelemetry gives you an option to integrate additional enrichers, whatever they call it there. So you can add additional data, which I think it does by default. For example, if data is exported from certain clusters and certain namespaces, it would automatically add those labels. So you don't have to manually do anything. It's surprisingly a lot that libraries and cluster and like infrastructure level instrumentation and so all this enrichments can provide without developers being involved anyhow. It's great that they are involved, but if they don't want and stuff, so the only thing you need to do is like make sure that it's in place and then educate them to actually at least use those. So they don't bother adding additional spawns, traces, logs. But even like, for example, with logs, you can normalize those logs without involving them. You can just convert them with, again, OpenTelemetry or FluentBit and stuff like that. So that's what we actually do. So we try to take as much load from developers as possible. But best if they actually cooperate. But if they don't, they're busy with, other reasons, you can still do a lot with the infra tools. The other important aspect is business level KPIs. So usually business uses some gut feeling. In some cases they use BI. So it's in some other place. Again, it's hard to tell. Grafana is not a great tool, but it basically has a bunch of data sources. So you can, and some companies even use Grafana to visualize business metrics, not infrastructure. So depends. It's a matter of taste and choice. At least having some business level KPIs documented and clear, so that even if it's not automated, you can somehow have reasoning about this is great. But best would be if it's programmed. So if it's somewhere there, and then you have a clear sort of understanding, and then you can also correlate. Because again, even CTO or CEO complaining something is wrong, then you have a proof that it's not that painful. Okay, you don't have to overreact. So basically, key concepts, technical issues and business impact is clearly together. It's visible and you can correlate this. And revenue and user basically impact is also like visible, and dashboards are shared so people can jump back and forth and see. mostly it's going to be tech people trying to understand the business part and correlate. So problem with this, as I mentioned, BI tools only, they are living in their own world. Mapping between, this part is not happening, our dimensions. KPI. So when you're getting some basic setup, then it's gone. Like business evolves in one direction, but you never get back to update. You have to maintain it. I don't know, if you have a person who is thinking this way, then that's great. If not, then I don't know, you have a problem basically. Maybe it's on CTO's shoulder too, because that's those are people who are connecting business and tech together. So pipelines, and obviously we are dealing with this kind of data. You have to be able to process this data. I don't know if you guys don't know OpenTelemetry, please check it out. I think it's already a couple of years that existed. Basically, industry is trying to standardize this stuff. It's great stuff. Some forked it. I think Grafana forked it. I don't remember how is it called, but they have their own version. AWS forked it and maintaining and patching for own structures. Even I don't understand why don't they just like bring everything together. But great stuff. You can do a bunch of things. It's like central and visible, and so it's not like hidden in different places. You can control it. You have flexibility. What you can do, you can besides this anomaly detection and whatever, you can also do PII protection. That's what we did in combination with Honeycomb. So you would clean some customer sensitive data before it would exit your system. You can do spike controlling even with that, like a whole bunch of things to, basically it's a great tool, and it's not in a developer's side. It's just somewhere on infra where you have control over that. The challenges is that it's usually become a single point of failure, though OpenTelemetry recently introduced the operator. So, and that means like individual stacks or containers can, or workloads can get the OpenTelemetry agents connected like a sidecar. So you still have a centralized place to control it, but it's not like single service that can blow up and then you lose stuff. So there are ways to take care of the single point of failure. Routing, it can get really complicated. So if you let people complicate, then they will complicate. So you shouldn't really do much stuff in there. And back pressure, that's we also had that. Sometimes that tool itself becomes a problem. So you have to make sure it can scale on its own, so it doesn't lose the messages, so you don't get blind very, very much. So, but it's great stuff. So if you don't know, check it out. And they have like two things. They have main distribution with a bunch of imports, exports, and processors. But there's also community repository, which gives you even more tools to modify and basically implement your telemetry pipeline. So anomaly detection. This is the part that I don't like most, because we're very much using Grafana on premise, and there aren't any mature anomaly detection tools. But what it is gonna give you, anomalies are cool. You can have those bands, and they can see the weekends and whatsoever. And so whenever there is some sort of problem, so single line is not enough, like I mentioned in the beginning. So it's cool stuff. There's no manual rules, so the system can adopt by itself, and we detect things way better than you would do with the lines. You have different type of false positives or false negatives, so it's different, but it's better, much better. So the difficulty is to implement. So if you're using Datadog or other system, AWS has CloudWatch has its own anomaly detection, which is also good. Those are fine. But if you're dealing with your own Grafana, at least whatever we were running, I didn't see any obvious solution to this. So the problems with this, you expect a magic, which is not. So it's slightly better than the regular things. And then anomalies fire on standard situations, which is, I don't think it's a big deal. You know that you were supposed to have a campaign. I hope you communicate and have some sort of registry when things have to go wrong actually, and it's planned. So your infra guys know what's happening, or SRE guys know. So basically same topic. telemetry drift detection. So this is, if I simplify, it's just understanding when, okay, let's put it differently. This is monitoring your monitoring, or observability for observability. So this is basically seeing when your observability actually gone. You need to have some sort of second level observability. Usually, even us, we monitor our monitoring with the same tools, but you need to have some sort of external safety net that tells you that, hey, you're blind right now. External health checks, there are a bunch of tools you need to combine. Let's say if you're using AWS, then you could go with external health checks and stuff like that. So you can spot those. So basically, you're not surprised when stuff are not there. Yeah, you can. The other thing is like you can evolve your schema. You can let people to change stuff, and then you'll know when they break it. You need some sort of testing there. So what is this? The usual problems are, I don't know, Prometheus is gone, storage is full, and some signals aren't just there, or I don't know, something went wrong. So it's standard challenges, but you need to have this. This is really, really important. Otherwise, you'll miss important events and negative events. So explorers, those it's a powerful tool. You just query and the stuff, and once in a while you have to go through and understand why are you leaking, what is happening, some sort of sanity checks, or if, let's say, your standard dashboards don't catch stuff, you can go and find things like explore. So you need the option to do this. Problem with this is like query language is usually complex. It's pain to deal with. Depending on a stack, you have to do with your own. Yeah, nowadays there's this AI stuff that helps you to do this. GPT is always there, but still, we had a case where we actually asked Amazon Q to give us a query about specific case, and it basically hallucinated. So it gave a query that didn't work. So yeah, it's not easy, and those things also change. So for example, on Amazon sites, they pretty much often introduce new way of querying the CloudWatch. So yeah, you have to keep up with this. Saved queries. So what we do, we have a folders and organize stuff, and then encourage and train people to have shared space of saved queries, so that they can quickly react and understand stuff. And so this can become expensive. Amazon did a bad job, even though we're a partner. But I'll be transparent about this. Look, when you were querying logs in CloudWatch, it was only 100, the limit, like in the beginning. But then somehow they changed the limit to 10,000. So default query would come with 10,000. It means you would just, I don't know, on every default query, you would just do way more queries. So there are not default guardrails. I don't know, maybe this is education can help you to take care of this, but we have limits. On Loki, for example, with Grafana, we usually set the limits to not really expand. Other stuff. So alerts. I think we're getting into another space. So the alerts. It's basic stuff. So that's how you catch things. Problems with alerts usually is there are a bunch of alerts, and we have so many alerts, so many different kinds of alerts, and ideally, you organize this somehow. So you put them into some folders and then assign those to specific teams or people to take care of own services full stack, including alerts, so they keep the hygiene. And also, basically, I encourage doing this matrix organization where your infra team or platform team will supply with the tools, but actually the teams, basically, infra or platform team enables developer teams to do stuff. So without going too deep into infrastructure tooling and understanding and stuff. But you have to give the ownership to actually dev teams, because infra guys don't know much what's happening in the product. And then at some point they have to deal with application level metrics, business level metrics, which is great, but you cannot really expect people really deep into infra understand the high level. So that's a problem. The ownership is a big problem, and sometimes you're just not testing or throwing some stuff there and keeps failing. Our team also does it. When I'm on call, for example, team would just previous day release some stuff, and then night comes, and then I have a problem. So I have to complain about this, but that's a standard story. The other problem is descriptions and runbooks. So descriptions are sometimes not relevant. So you have to make sure they are understandable. There's not too much noise in there, and runbooks are in place at least for the critical cases or the cases you expect your on-call to take care, or I don't know, whoever. So statistical anomaly. This is I think we kind of touched this. So ideally, you have such a stuff. You don't have, basically it removes all the like basic alerts and gives you more intelligent alerts. It's better for detection, easier to spot outliers. Yeah, again, expectation is like you hope it just works, but it doesn't. So as great as it's not 100% basically. So sometimes they are too sensitive. You have to have your band slightly bigger, where you risk actually losing stuff. So, but yeah, you have to make decision. Something has to be done there. So models depends if you're running those models on your own. That's a problem. If you're dealing with cloud providers, then training happens over time. So if you introduce new system, if you migrate, and if your users change, behavior changes, or you introduce new service into, then this thing changes, and you need to be patient actually. To maybe you can just increase the band, and then over time just bring it back. So. Basically, you don't have those problems, but that's a drawbacks of those things. Multi-signal, this is again, it's cool stuff, but I wouldn't do this. It's like if you are basically combining multiple things in the same condition, you start programming in your observability. This can become really nasty. So it's better. You can combine, have complex use cases, but usually the basic stuff should cover your needs. If you are doing programming there, then either your infra guy is bored, or you have, some sort of complex stuff, which you don't want to do. It's going to be hard to maintain. So it becomes too complex, and ends conditions programming in this level is actually not easy. And alerts usually get duplicated, which is, it's good or bad. Maybe it's safer, but I don't like it. I know that it exists. So SLO-based alerting. This is nice. So it gets to the same topic as the business metric monitoring. I'm going to have to speed things up. So you have to do this if you can actually chase business and get the indicators. That's a problem. Usually business don't want to give or can't give those kind of things. So maybe you have to come up with some indicators on your own and basically monitor those. Budgets and windows and stuff like that. You can make many mistakes here. So instrumentation, if your team is cooperating, then I would go with white box. Then it's nicer. They expose specific events. It's not just like random technical events, which is at least something. But this is basically having SDKs and applications exporting actually business level spawns and stuff. Then you understand what's happening better, and your team also is owning this. If that doesn't work, then you go. I think black box is a different thing. So there are three things. Black box is very much like when you're poking your system from outside. It's like external health checks. That's what I was talking about when you're testing your observability or monitoring. So you pretty much probably have those external health checks, synthetics from Datadog, AWS, and so you can do with Prometheus and Grafana, same story. So usually you check the DNS records, TLS, and whatsoever. Problems is that you only poke specific areas, so you don't test the entire thing, but it's something. At least you know when the application is gone. This is the part I love most. Discovered again recently, though it's probably not new. So with this eBPF, and if you are in Linux, hopefully you are, then you can very much basically understand what your system is doing by just like hooking those things into the kernel, which is now supported out of the box. So I don't think I checked on a couple of Kubernetes clusters in Hetzner, which we maintain, and AWS and GCP, and all of them support this. You can get there is net data, there is a bunch of Pixie, I think a bunch of instrumentations, and those guys give you bunch of things. Like you can get networking, topology, security issues, whatsoever. So pretty much does what tracing does, what metrics that you can extract those kind of things out with eBPF. So, and we're using Linkerd. I would believe they also probably do that. So they pull this data and then push it to Prometheus, and then you can basically visualize this stuff. So this is cool stuff. Check it out if you don't know. I even like how the eBPF thing, whatever, looks like. So problems is that, basically, people don't trust it because it's like too much noise and whatsoever. So, and the other problem is there's a compliance issue. So you see too much, actually. And so sometimes, people can block because you can get access to the data you shouldn't be accessing and export it. So you should be careful with that. This is basically at the opposite of white box instrumentation. So if you, let's say your team doesn't want to instrument applications for OpenTelemetry, you can use for tracing, you can use this, or you can do with the sidecar. So both are possible. So if you don't have tracing and you don't have developer capacity, you still can do it. And I believe you should have at least one of those there. And then as soon as your developers see the benefit of it, they're gonna ask for options to inject own data there. So agents SDKs, it's just a different way of doing stuff. So you can, like I said, with OpenTelemetry and Datadog, you can just deploy your agents and they're gonna do those things. SDKs are very much used from inside, so have own issues. Now we're getting to the storages. So basically, for metrics, we're dealing with time series databases and then logs and whatsoever. So they're supposed to be scalable. Those things supposed to have way higher availability guarantees than your application itself, because that's how you are monitoring. So if you really have to have those guarantees, then, and you cannot provide Go for cloud solutions, I think there at least you legally can, have better alternatives. If no, then recently, for example, we had challenges with Prometheus, and we'll be migrating away to Victoria metrics. So I don't know how it's going to go, but Prometheus is not redundant, and Tanos is like, it's pain. Mimir is like giant, so we'll have to see how it goes. But default thing is not sufficient anymore. So as it brings with its own problems, it doesn't give you replication out of the box. It just requires a lot of resources. It doesn't do offloading out of the box, so it's really pain. Logs, same-ish, same problems very much. Again, you should have all the storages, hot, warm and cold. There are great tools that can do offloading out of the box. I think Loki does it by default. It's so far it's great, except if you're throwing too much work on Loki, so it's gonna kick you back. So you have to tune it. That's what we do. It behaves, but that's my favorite tool so far. For logs, you have to be careful not to pour too much stuff. You need some way to control the logs going out and indexing and whatsoever. And you have to have those windows. Otherwise, the guys can kill your, S3 consumption or something like that. So trace storage, same story. So traces now, we're using at least Tempo and Sentry. Depends, developers prefer Sentry because it's also APM. By the way, I just realized I didn't have this application or people room also. Those things, it's really part of monitoring too. So I believe you might have it. That's why people use Sentry in the first place. So same story here. Tempo, traces. Basically, it's great. You need to take care of storage. Tempo does a good job. Also offloads to S3. I would recommend if you are not already doing in Sentry, you do it with Tempo. I'm not anyhow affiliating or recommending, sponsored by Grafana, but it's to me, it's a good tool because you can do cross clouds, you can do, no clouds and whatsoever. So, retention strategies, hot, warm, cold. So basically you need to be aware of those and you need to pick tools that can let you to offload the stuff and query back. You shouldn't have like a long retention period for production environment. Keep it like maybe 3 months. For audit logs, you have to, I think, legally keep it at least a year, and then if you are in specific environments, you have to have it longer. So you can apply different strategies here, but yeah, that's something you're gonna deal with. Aggregation transformations, I don't know if anyone does this, so it's also a topic. Ideally, you pre-aggregate stuff that it's easier to query, but to be honest, I haven't seen anyone doing this, and we also do it ourselves. We just use default stuff, but it's something to know. Dashboards, it's like same as alerts and metrics and whatsoever. So I'm obsessed with dashboards. So we are even distributing a couple of dashboards on our own. You can find it in Grafana dashboard directly. I think you should have standardized dashboards. That's what I'm fighting with inside our company a lot, to have a proper dashboard, because when shit hits the fan, that's what helps you actually quickly to spot the problem and then chase the specific issue. And you can do really great stuff. You can get creative. You can see in the pictures that you need to have a standard understanding, and everyone basically not just like have a dashboard, but make sure everyone agrees and understands all the details in the dashboard. Because we build a complex dashboard, we gave it to developers, and then people don't use it. Turns out they just don't understand what is it, which is basic, but sometimes those kind of things stopping. So starting points, and then for on-call, I think you need this as like a communication tool. That's also like in the dashboard, we're pretty much putting all the service components, application components. So people understand even there is a flow, like the request goes from top to bottom, and then those are the components involved. So you can visually also, like, though it's not a tree, but still something. So people don't use dashboards. So in some places they just directly go and do exploration, which is very surprising. And I don't know, no offense, guys, but if you're not doing it, then use it. So don't use just explorations. And it's built just once, never updated. Sometimes you add new components. You should do that. And basically we also split those. We have different layers: layer 0, 1, 2, 3, 4. And so one is like highest level, which is just about a couple of components, and then lower, and then lower, and then just on a single service level, we have Kubernetes dashboard. We have each like RDS, whatsoever. Those guys also have dashboards, though you can have them in a cloud too. But we basically like looking at the things from our own angle. So do those service maps. This is also rare. So Datadog provides by default. I think you can build one with Grafana stack, and you can source this from different places. eBPF helps you. I think NetData gives you, so there are different tools that can actually extract the signals and build a live service map. And we internally came up with some tool we're still using for our customers, and that's giving us a live dashboard of the components and their health and stuff. So basically try to use this. This is cool. Datadog dashboard is very helpful to understand issues. I think I kind of mentioned this one before. If it's too complex, then it's hard. What is this one? You cannot jump back and forth. Some of them are static. By the way, Linkerd provides some sort of map on the fly. So also use Linkerd if you don't. It's super simple. You deal with a bunch of graceful shutdowns, restarts, and whatsoever. So it's really helping you a lot. And it also gives you these kind of things. And also metrics that you basically, so it can, since it's wrapping around different containers and taking care of your communication, it does also export the ins and outs from each container. So you can clearly see if there's, let's say, a problem, which one is failing, blah. So if you don't have experience with that, check that out too. But that as a side kind of effect brings you also the map. So label budgets. This is also like, I don't know, it's a thing apparently, but I haven't seen anywhere. And I've dealt with about 30 companies in my experience so far. None of them actually does it. Probably this is, if you have a giant company, then you want to basically dedicate some, buckets of, capacity storage to the different teams, and you could do it obviously with the label. So schemas, this is cool stuff. Kind of touched it in dashboards. So you have to standardize it. How we do it, we came up even with Terraform modules that you can give your developers to provision own alerts and stuff. So that gives you standardization. All the labels and everything is naming convention stuff. It's very very cool. So you don't have to deal with each of them, their taste, the emojis and blah. So you have a standard, and your own code can basically interpret stuff, and that's just part of it. So basically, you can enforce. So it's living way of right. So ownership. That's kind of touched it. Yeah, you should own the platform. You should own the storages. You should own the modules as an infra. I'm talking from infra standpoint because I'm mostly dealing with infra. But you should give a freedom to developers to basically put their whatever dashboard, whatever chart, whatever alarm they want, whatever condition they want. But that alarm is supposed to be hooked to your on-call system. It has to be structured exactly this way. So it's that brings accountability. Who wants what, and then a better maintained dashboard. So also, like, devs are supposed to build on dashboards. They understand stuff better. So blaming, the story. So ownership, clear ownership actually solved that problem. And onboarding or offboarding is like we are training them how to use those kind of things. So I think there's this one thing I would like to. This is last slide. I promise. So this is might be important unless you guys already do it. So if you're doing with LLM, which pretty much everyone does, not as a cursor, but like integrated into your own system. So use basically tools like Langfuse or Portkey. So that's letting you to see what's happening, what communication goes between LLM and you. So gives you control over prompts. You can do tests, specifically some scoring, and basically you can route if you're using let's say lang chain or lang graph and stuff like that. This is like very necessary to do. You can monitor latency errors and the costs. You can test different models and whatsoever. It's super basic. Instrumentation is pretty much like nothing. So it's just an SDK. You can replay, inspect, and debug, and take care of hallucinations. And so you can optimize, like Portkey lets you actually load balance between different LLM providers. If you don't know, again, use that. So issues with this, like it can explode. So look at that, and there's a risk. This one is like really my favorite one. It goes out of control very much, and you can put the data that is basically aren't supposed to be there. And I guess what is this one? Hard to define good quality signals. Yeah, it's really difficult to test those, but I think it's a totally different story. So go look into the Portkey and Langfuse, and they have own sort of trainings how to test LLM and prompt, and it's just part of observability. It's not exactly the infrastructure level observability, but if you're doing LLMs, then you have to deal with this. Thank you. Sorry, guys, for such a long speech, but I hope I did a good job. Thanks. Questions time.
Thank you so much. Thank you so much. I think we have only time for one question because everyone else is already leaving, and I also have another meeting just since 2 minutes. But thank you so much from my side. That was a really crazy overview. I think we could have done 2 masterclasses from this. So we should maybe do another one and dive deep into some of the stuff that you said. Before I hand it over to the last question, I would say if someone else has questions or wants to ask Aram something, just write it into the Slack channel. We have the Slack channel open. Just directly contact him there. And then we can also maybe do a deep dive if Aram has time and wants to do it sometime. If there is any questions, I would open it up to anyone. More people leaving. Okay, I think everyone has already left that might have had a question. So if there is no questions, again, you can ask them in the Slack channel later as well. Yeah, thank you so much, Albert, for the overview. It was really cool.
Thank you.
Bye, everyone.
You guys have a good evening.
See you.
Bye.